the top of this page in your notebook, I want you to write lesson 1.4. And maybe you should just tell yourself their notes, in case you're wondering what's this about. We're taking notes in your notebooks today together. And we are going to be solving, so our objective today is to be solving, it says right over there, I can solve equations in one variable that contain more than one operation. Well, we'll shorten that up to solving multi-step equations. So what's the objective here? What are we going to be doing on this page in our notebook when we're taking these notes? We're going to be solving multi-step equations to meet our learning goal of solving equations in one variable that contain more than one operation. So it should take us more than one step of work today to solve the equation. Now, I'm going to make another statement right here at the beginning, and I want you to write this in there. Note it's going to start with the word usually. Usually, I don't say you must, but I'm saying usually it is better to undo, remember we undo operations when we're solving. So usually it is better to undo addition or subtraction first, and then go about doing what needs to be done next, okay? So usually, I'm not saying you have to, but I'm sure going to try and make your life easier, okay? Now, in order of operations, when we are evaluating, when we are simplifying an expression, in order of operations, we would take care of the multiplication and division first, and then we would go back and do the addition and subtraction. So I'm not trying to mix this up with order of operations. This is solving, not simplifying. We are solving, and when we solve these, we are going to use, we're just going to undo addition or subtraction first rather than the division or the multiplication first, okay? So, let's just go right into practicing. Solve. Here's the first equation we're going to solve. Negative 4x, or negative 4, excuse me, plus 7x equals 3. So our goal is still to isolate the variable, get it by itself. So we have to look on the side where the variable is and say what's happening over there. So there's a couple of things happening on the side of the variable, right? What's one of the things happening, Devin?
There's a negative 4.
There's a negative 4 being added to 7x. What else is going on? Aiden?
7 is being multiplied by x.
Yeah. 7 and x are being multiplied by each other, so x is being multiplied by 7, so we really have a couple of things to undo here, don't we? And what did I say? We should undo what first?
Addition.
The addition or subtraction. So we're going to undo that adding that negative 4. What do we have to do to undo adding a negative 4? What do we do there, Shay? Add 4 to both sides. Add the opposite of negative 4, because opposites combine to become what? 0. Opposites combine to become 0. So if we add the opposite of this negative 4 here, now, why can we read this addition here? How come I can read that as addition? I can read it backwards. 7x plus negative 4. How come I can read that backwards? Shay? Order doesn't matter in addition, does it? You can say negative 4 plus 7x, or you can say 7x plus negative 4. That's a big deal. Remember, keep that in mind. So these guys cancel each other out. They're done for. They're 0. So we have a 7x equal to 7. And now we have another undoing step. What are we going to do, Josh?
Divide by 7.
Divide both sides by 7. Divide both sides by 7, and of course the 7's now cancel out, and we get x equals 1. Our solution is x equals 1. Okay, I want you though to put this right here. If you want to divide first, because trust me, there are going to be times when that's the first move you're going to make, and you're going to be like, well, she said usually. She didn't say I had to do it the other way. So you can divide first if you want, but we have to be really careful when we divide first. Anybody know why it's a big deal if you're going to divide first? Okay, I'll tell you why it's a big deal. When we add or subtract first, to undo addition or subtraction, we just have to do it once on each side. Once on each side. But if we are going to decide to undo division first or multiplication, we have to do it to every piece. We cannot just do it once on each side. So let's write our equation over. -4 plus 7x equals 7. If you're going to divide by that 7 first, you're going to have to do this. -4 has to be divided by that 7. 7x has to be divided by that 7. 7 has to be divided by that 7. All 3 pieces. Instead of
Doesn't equal 3.
doesn't what equal 3?
The equation equals 3.
Instead of 1?
No, not 7.
Oh, I'm sorry. Do I have that part wrong? Oh, yeah, you're so right. Yes, it should be equal to 3, not to 7. I just got 7s on my brain here, don't I? Okay, thank you for getting that straightened out. Okay, we wanted it to be different. We solve the same equation. So we do it to every piece. Well, we just made this kind of ugly, didn't we? Yeah. Well, that's why it was ugly. Okay, but should we still get the same answer even if it is ugly? Oh, absolutely. So these guys are going to cancel out, and I now have -4/7 because does 7 go into 4 nicely? No. So those 7's cancel out. X is now just X, and 7 doesn't go into 3 nicely, so I'm going to have to leave that as 3 7's. Okay. Maybe it isn't as bad as we thought. What are we going to do now?
Add 4 7s.
Add 4 7's to both sides. Now when we add, we only do it on each side, once on each side. So now these guys, they become 0. Well, these have a common denominator, so we can add them together, right? 7's added to 7's is 7's. No, you didn't listen to my question. 7's added to 7's is 7's. But 3 of them added to 4 of them is 7 7's, which is 1. Yeah. So, did we get the same solution?
Yeah.
We did. Which one did you like better? The top one, me too. So, again, I'm going to say to you, it's not that you can't multiply or divide first, it's just you're going to maybe make more work for yourself, that's all. You're going to make it uglier. You better still get the same solution, whether you and your friend are doing it different ways, you should get the same thing. Okay, any questions? Okay, let's solve another one. So we are going to solve, I want you to put the word solve again. I want you to solve this one. 1 5/10, 1.5, is equal to 1 2/10 y plus, or no, minus, excuse me, subtract 5 7/10. Okay. Feel free to solve that. Go. I can guarantee you that this would not be a good time to do the undoing, the multiplying first. No. I suggest you go with my usually method. 0.6, he says. Oh, okay. Let's see if he's right. You know what? Whenever I deal with decimals, and I don't especially get to use my calculator, I always think of it like money. So 7.2 could be what in money? $7.20. 1.2 could be $1.20. So let's think about this. How many times do you think you could take $1.20 out of $7.20? Do you think you could take it out? It's a little bit more than a half. Could you only take out a half of the $1.20? Shouldn't you be able to take it out 6 cents? 6 cents, $1.20. Wouldn't that be? Yeah. You know, and remember the little trick when you're dividing with decimals. The number you're dividing by, you can move that decimal point over so you can make it into a whole number. Remember this trick? And then if you do it there, you got to do it into what you're dividing into. So I have to move that one. So I really have 72 divided by 12, which is 6. Yeah, the answer is 6. Okay. Did you? You just decided to change it. Bummer. Okay. Questions on that one? Okay, we're going to do another one. Solve. So I will try and keep that for anybody who's still trying to catch up. We'll try and leave a little bit of that there for you. And here's our next one. Solve. Oh, and this one's going to be so fun. Here we go. 3/4 A plus 1/2 equals 7/8. Well, what would our first move be in this one? What would we do first in this one? AJ?
Make all the fractions so they all have the same denominator.
Okay, why would we need to do that? Because convince me that it's worth doing.
So it's easier to solve.
Okay, why? Because what are we going to have to do when we solve? What would be our first move in solving this one? Before we maybe even rename it, what would be our first move in solving it? Devin?
Subtract 1/2.
Subtract 1/2. So we're going to have to subtract 1/2 from both sides. So we're going to have to take a half away from 7/8. Can we take a half away from 7/8 without them having the same denominator? No. So you're right, AJ. We need to rename this equation. We are going to rename the equation first of all. So would you just put that over here that that's what we're doing? We're not even starting to solve. We are just rename the equation. We're going to rename it. Well, what's the common denominator going to be then?
8.
8. Okay, so 3/4 as 8. What is that? 6/8. 1/2 as 8. 4/8. And 7/8 as 8. 7/8. We don't need to rename that one, do we? Okay, now you can go to work solving. So our first move you said was to subtract the 1/2. Well, now it's 4/8. So we'll subtract 4/8 from both sides of the equation. Whatever we do to one side, we do to the other. We now have 6/8 A. These guys are gone. And we have what on the right side now? 3/8. Okay. We have to do what now? Divide by 6/8. Okay, so can you tell me how many 6/8 there are in 3/8?
Negative something.
Negative something. 2? A half. Because 3/8, we're trying to take a 6/8 out of it. Which one's bigger? The 3/8 or the 6/8? So we're trying to take something bigger out of something smaller. Do you think we can get more than one out of it? No. So it probably is a half. But we don't know that, right? Typically, Austin, did you know that or did you do have you already solved it? You already solved it. Well then, Austin, will you tell us how you solved it?
I did 3/8 divided by 6/8.
And you knew that that was 1/2.
Well, like, just switch it. Then you like multiply them, and then I got 24/48, which is
You get 24/48 because you multiplied them. So in other words, you did multiply by the reciprocal in the end, right? Okay, so should we just show it that way right away? Just go to multiplying by the reciprocal. So 8 over 6 times 6/8. Why did I use 8 over 6?
That's reciprocal.
That's the reciprocal of what A is being multiplied by. So 8 over 6 times both sides. Again, this is what I'm doing to both sides. I didn't change the equation, I'm just multiplying by the reciprocal. Because when I multiply by the reciprocal, what's going to happen here? All these guys disappear. What can we do? Instead of having to say 24 over 48, can I make my life easier before I multiply?
Yes.
How, Devin?
You can reduce the 8s are just going to be 1.
The 8s are just going to be 1 because 8 goes into itself one time, and we have 1 up and we have 1 down, so we can get away with that. And
3 goes into 6 twice.
And 3 goes into 6 twice, but you got to do it upstairs somewhere too.
So then there should be
So 3 goes into itself once. Okay. Well, look at that. Now we can say 1 times 1 upstairs is 1, and 2 times 1 downstairs is 1/2. Yeah, 2, which is 1. So we get A equals 1/2. And if you multiplied first across, and like Austin said, and got 24 over 48, should that simplify to 1/2? Yeah.
Yes.
Yes, okay, thank you. So the answer is A equals 1/2, and we said it should be less than 1, shouldn't it be? We said it should be less than 1. Okay, I want your books open to page 35. We're going to do the check it out problem on that page, and then we can be done here. So I want you to, in your notes after you have that page, we're going to actually to the about the middle of it, so I want you to put in your notes, where did this problem come from, because I'm not going to make us write down everything about it. So check it out, page 35, and it's about the middle of the page. So I'm not going to make us write out all the words, so that's why we're going to write right now that here's where you can find the information for this problem. So we're going to do, actually we're going to do the number 4 one, so number 4, okay? Everybody with me? Sarah paid $15.95 to become a member at a gym. She then paid a monthly membership fee. Her total cost for 12 months was $735.95. How much was the monthly fee? Well, we're going to write and solve an equation for this. So if we're going to write an equation, we need to first pick a variable and describe what our variable is representing. So what variable do you want? And what's it representing? Go ahead, Shane. F for fee. What fee for what is it?
Monthly.
Monthly fee. Okay, let's do that then. F is monthly fee. So we have to be more specific because I think there's another fee involved also, right?
Yes.
Okay. So F is monthly fee. We always describe our variable and then we use that variable in our equation. Okay, who thinks they can tell us what the equation might be for this one? Go ahead, try and write something down in your notes. AJ?
1595 plus F12 equals
Can I make that 12F?
12F.
Yeah, thanks. Okay. Equals
739 or 35.95
$735.95. By the way, in your equation, you can leave the labels out, okay? So, does this make sense? Did he only pay $15.95 one time? Or she? Sarah? Yeah, one time. Plus, if you add how much she paid per month, or paid for the monthly fee times the 12 months, that money added to the $15.95 one-time fee should equal her total. Okay, go ahead and solve that then. I think this looks like a great equation. We'll see if we get a reasonable answer. It even makes sense. I will let you use, well, I don't think you have to use your calculator. I think we're going to be good because we already experienced some of these numbers today. So, I think all is going to be well. you get?
$60.
$60? Anybody else get that? Oh, yeah, look at there, 72 divided by 12 again, isn't that cool? And then attach a 0 to it. Okay, so this is $60 what? Per month. $60 per month would be our final answer. $60 per month. You can use the word per if you want instead of the correction mark. Okay, does that seem reasonable? Does that seem think it would make sense? Yeah. $60 12 different times. Yeah. Well, 10 times is $600, right? Yeah. And then get a couple more months and add that $1,595. Our answer seems reasonable, doesn't it? Okay. Okay, go ahead, get out a sheet of loose leaf paper, get your assignment written down. Good news, you don't have quite as many problems to do today for homework. Anybody need to ask questions about this last problem we did? Before I get rid of it.